Hello from West Virginia. Hello from somewhere. Okay, I know it is time for joke of the day, and you know it's time for the joke of the day, and we cannot wait for joke of the day, so let's get into it. So why did the Oreo cookie go to the dentist? I mean, why would an Oreo cookie go to a dentist? Because it lost its filling. Okay, well, we are not lost on the power rule of logarithms. So what the power rule of logarithms does is it allows us, as does the product rule for logarithms, as does the quotient rule for logarithms, it allows us to simplify and evaluate logarithms. What the power rule says is, I've got a b and an m, they are going to be positive real numbers. So I'm talking about real numbers, I'm not talking about complex numbers. The b is not going to be a 1, so the base down here is anything other than a 1. And p is a real number. So once again, we need to have a not a complex number. Also notice that the base and this index here, they are going to be positive real numbers. So we're not dealing in negatives. But the bottom line is this. Here is what our power rule says. It says that if I have a log of a base to this number, but that number is raised to an exponent, in order to simplify or expand, I can take that exponent and I can slip it down in front as a coefficient. In other words, multiply it to this log base b of m. So you can see, just slip it down in front and it looks like this. So what this does is, again, it allows us to evaluate and simplify, and as with the product rule for logarithms, as with the quotient rule for logarithms, this applies as well to common logs, which again is base 10, or to natural logs, which is base e. And remember, when it's base e, we simply write it as lowercase script ln. So let's take this power rule and let's expand our logarithmic expressions. I've got two examples of this. So what happens again is I have log base b of x, but that x is being raised to the 7th power. So my power rule says I can take this exponent that's up here, I can slip it down front as a coefficient, and then when I slip it down in front as a coefficient, I am multiplying it to log base b of x. Now, if I knew what log base b of x was, if I knew the decimal or the number value for that, I would certainly take a 7 up and multiply it to whatever that number is. But I don't know what log base b of x. Remember, in order to evaluate that, that would indicate take this b to an outside power, it's going to equal this number on the inside. That would be like b to the y equals x. And I don't know how many times I need to multiply b by itself to create that x. It's not going to happen because I can't multiply b by itself to create an x. Not possible. So therefore, this log base b of x, that is as good as that's going to get. And so therefore, this is as good as that's going to get. But we did use the power rule to slip that down front as a coefficient. So let's take a look at this one. Now, lots happening in here. First, we need to understand when we take something to the 7th root, remember, root is the same thing as a rational exponent. So what we have here in terms of rational exponents is a natural log of x to the 1/7 power, x to the 1/7, because the denominator in a rational exponent, the denominator indicates root, so that's the same thing as 7th root. Now, the reason that I wrote it this way is because now I can take this exponent, and as the product rule says, I can slip it down front as a coefficient. So when I slip it down front as a coefficient, I'm going to get 1/7 times natural log of x. Now, if I could evaluate natural log of x, by all means I would. But that's going to indicate this base to the outside power. Now remember, what's the understood base when it's natural log? That's an e. So that would be e to some power is going to equal the number on the inside. How many times do I have to multiply e by itself to create an x? Well, I can't multiply e by itself to create an x. So it's not possible to evaluate that. So therefore, again, like the previous one, this is as good as it's going to get, but what I do know is I'm going to take 1/7 and multiply it to the natural log of x. Now, we talked before with our product rule and our quotient rule, and we said not only do they allow us to expand, but they also allow us to condense. So if I'm heading in this direction, I'm expanding. because it's stretching it out a little bit, expanding it a little bit. So when we take that exponent and slip it down in front as a coefficient, we are expanding our logarithm. But when we work backwards and we take that coefficient and slip it up as an exponent, we are condensing our logarithm. And they go back and forth. So you can either take the exponent, slip it in front as a coefficient, or you can take the coefficient, slip it up as an exponent. So let's try a couple more. We're going to condense each of these logarithmic expressions. We're going to write the expression as a simple logarithm whose coefficient is a 1. So if you take a look at the first one, it's already expanded. It's a little bit longer. So we can take this coefficient, we can slip it up as an exponent, and when we do, we'll have log base b of y, and that's a capital Y, please excuse me, but y to the third power. So if we knew what y was, we would certainly take it to the third power and we multiply y times y times y and get that value, and that value would go right here and we do log base b of that value. We cannot evaluate this because in order to evaluate it, we would do base to the outside power, and that would be b to the x is going to equal this number on the inside, y to the third. But I don't know how many times I've got to multiply b by itself to create a y to the third. In fact, I can't multiply b by itself to create a y to the third. It's not going to happen. So therefore, this is as good as that one gets, but it certainly has been condensed. And there's my answer. So now let's take a look at this one. 1/2 log base. Now, when it doesn't look like the base is there, what is it? Yes, it's a 10. So 1/2 of log base 10 of 1,000. And so we can use our power rule for logarithms to say, let's take this coefficient here, let's slip it up as an exponent. Now when we do that, we have log base 10 of 10,000 to the 1/2 power. Now 1/2 power indicates what? Now remember, the denominator indicates root, so that would be second root. But when we have second root of a number, that's really just square root. So we're going to ask ourselves, what would we multiply by itself? The index of 2 that's set here indicated 2 times, multiply a number by itself to create a 10,000. Well, that's 100, because 100 times 100 will be 10,000. So this part right here is just 100. So we have log base 10 of 100. We can evaluate this, because remember, what this indicates is base to the outside power. What's the understood base? Yes, it's a 10. So 10 to some power is going to equal the number on the inside, is going to equal 100. And this asks me, how many times would I multiply 10 by itself to create 100? Well, 10 times 10 is 100. So my exponent then is going to be that 2. So this is a 2, meaning that all of this evaluates as just a 2. So the condensing allowed me to evaluate the logarithm. So what happens again, just to review, the power rule of logarithms simply says that you can expand your logarithm by taking the exponent on this factor, slipping it down in front as a coefficient, or if you have a coefficient, you can take it and you can slip it up as an exponent. And all of this allows us to evaluate our logarithms. I hope it helps. Have a great day.